Hello and welcome to this Java video tutorial, and before I get started on this one, I'd like to thank everyone that has subscribed to the channel over the last while. I'd also like to thank everyone that has left a comment on the videos that I've uploaded so far. I've received some very positive and encouraging comments on my videos, and that tells me that the videos are serving their purpose in trying to help you guys to learn how to program in Java. Okay, so what I'd like to do with this video is cover a very important topic in programming, and that is creating conditional blocks using the if statement. Now, I have some other videos on this material that's part of my Java Fundamentals playlist, so you'll find a link to those videos up here somewhere, and I'll also link to those videos in the description below. I have one video that's on relational operators and Boolean expressions, which we'll do a bit more of in this video, and I have an introductory video on creating conditional blocks in your programs and creating programs that have multiple pathways of execution. And that is really an introduction to the if statement and the syntax of the if statement. But I'd like to delve into that topic area a little bit further in 3 videos that I'm going to make. This is going to be the first one, and we're going to focus in on the very basic building blocks of conditional logic in this video, and then in the next video, in the second video, we'll go on to take a look at the syntax of the if statement, and then in the third video we'll go on to look at how to create more complex conditional blocks using the if statement in Java. So this is the first in a 3-part series that will hopefully answer all the questions that you have on creating programs that have conditional blocks using the if statement. Okay, so the way I'd like to do this is I'd like to first of all have just a little bit of a refresher on the relational operators in Java and also the Boolean operators. Okay, so let's have a look at those. In Java, we have a set of relational operators, and those relational operators are shown here on the screen. Okay, so what relational operators do we have? Well, we have the greater than operator, we have the less than operator, the greater than or equal to operator, the less than or equal to operator, the equivalence operator, and the not equal to operator. Okay, so I just want to make a point on the equivalence operator because it's an important one, and that is that in Java, a lot of the times when students start to program in Java, they get a little bit confused between the single equals and the double equals symbol in Java. Of course, the single equal symbol in Java is assignment. When we want to assign a value to a variable, we use the single equal symbol. However, when we want to check to see if something is equivalent to something else, we need to use the double equal symbol. Okay, so that is this double equal symbol here. Now, when you see an expression that contains one of these relational operators, that means the output of that expression is going to be a Boolean value. It's going to be a value that is either true or false. Okay, so that's something that you need to keep in your head whenever you see a line of code that has one of these operators in it. Then you know straight away that the outcome or the evaluation of that line of code is going to be a Boolean value. Okay. So along with those relational operators, the other things we need to know are the Boolean operators. And the 3 Boolean operators that I'm going to focus on in this video are the AND operator, the OR operator, and the NOT operator. So the AND operator is the double ampersand symbol, the OR operator is the double pipe symbol, and that pipe symbol can be found on the right hand side of your keyboard, just above the shift key on the right hand side. The NOT symbol then is how we negate Boolean expressions. So if we have a Boolean expression that represents something, we can get the opposite of that just by using the negation operator, and we'll see how we can use that in a minute. Okay, So how are we going to get our heads around using these relational operators and these Boolean operators? Well, the way we're going to do it is we're going to have a look at 10 different questions that give us practice at using and constructing Boolean expressions that use the relational operators and the Boolean operators. Okay, so here's the questions. We've got 10 of them here, and they're all English kind of statements. And what we're going to do basically is translate those English statements into Boolean logic. So one thing that you could do is, just to get a bit of practice at doing this, you could try out these yourself first of all, and then come back to this video and you'll see me going through the answers to each of these questions. So if you want to do that, pause the video right now. Okay, so hopefully you've had a go at these questions yourself and now you're ready to go through the solutions with me. So we'll go through each one of these questions bit by bit. And the way I want to do this is I want to kind of write this as a program. So for each question, I'll write a few lines of code that will allow us to write down the expression, write down the Boolean expression, and then it will also allow us to kind of test it out with different values. Okay, so you'll see that in a minute as I do question 1, and we'll follow the same pattern then for all the other questions. Okay, so let's look at the first question, and the first question states that x is equal to 100. Okay, so let's assume that we have a variable x. I'll just create an integer x here, and I'll give it a value. To start off with, I'll give it a value that isn't 100, so let's just say 1. Okay, and we want to represent the statement x is equal to 100. So in order to do that, what I will do is I will create a Boolean variable, and I'm going to call it Q1 for question 1, and I'm going to assign that equal to the answer to our question. Okay, and I'm going to put the answer in a set of brackets. The brackets aren't going to change the logical meaning of the expression that I write down as the answer, but they're just there really to just kind of separate the answer part out on the screen, so you'll be able to read it a little bit better. Okay, so in the brackets here, I'm going to put in the answer to this translation from this English sentence into Boolean logic. Okay, so it says x is equal to 100. Well, this is pretty easy because all we have to do is use our equivalence relational operator. So I'm just going to say x is equivalent to double equals the value 100. And that's basically going to be our answer to question 1. Now, I'd like to test that out. I'd like to print out the value of Q1, our Boolean variable. So what I'll do is I'll just put in a little system.out.println, and I will print out a little message to the screen first of all that says Q1 is equal to, and then what I want to do is print out the actual value of Q1. So I'll print out Q1 there. Okay, so the way this is going to work is when I execute the program, x will be assigned the value 1. Okay, and then in my Boolean expression that represents my answer to this question, x will then take on the value of 1. Okay, so let's imagine x now has the value 1, and we're evaluating this expression. So because there's an equivalent symbol here, of course that means that the outcome of that expression is going to be a Boolean value. And the value that it's going to take on will be, well, is 1 equal to 100? Is 1 equivalent to 100? No, it's not. Okay, so the outcome is going to be false. So we have an outcome of false here. So now Q1 is assigned the value false, and then I'll print out Q1 to check to see what value we get. Okay, so that's the way it's going to work really for each of the questions. So I'll put back in my Boolean expression here, x is equivalent to 100. And what I can do is I can save that program and I'll compile it. And we can run the program. So you see I get an output of Q1 equal to false. Of course I do, because I've assigned the value 1 to x, and we're checking to see if x is equal to 100. So of course it's not equal to 100. So let's change x to 100, save the program and recompile it. And I'll execute the program. So now we get a value of true. So we'll go through the same kind of process for each of the questions here, and we'll kind of pull apart and tease out each bit of the Boolean expression so that we can understand it and see how each of our relational operators and Boolean operators work. Okay, so let's take the second one here. And the second question states that x is not a positive number. Okay, well, I've already introduced my variable x, so I can just kind of assign x a new value for this one. So x is not a positive number. Well, let's give x a positive number to start off with. So I'll say x is equal to, and since this is question 2, I'll just assign x the value 2, which is a positive number. Okay. So how are we going to do this? Well, I'll put in my Boolean variable q2 is equal to, and then the answer to this is going to be, well, what is a positive number? A positive number is a number that is greater than 0. 0 is a neutral number. It's not positive or negative. So all the positive values are the numbers that are greater than 0. So how could I say not a positive number? Well, if I can write down the Boolean expression for a positive number, then I can just negate that and get not a positive number. Okay, I'll show you how this is done. So we can say, well, what's a positive number? Well, x would have to be a number that is greater than 0 to be a positive number. So I'm using one of my relational operators, greater than, to represent that x is a number that is greater than 0. So if x is a number that is greater than 0, then it's a positive number. So if I want a negative number, so not a positive number, I could just put in the not operator in front of the brackets here, and now I'm negating the thing that's inside the brackets. So inside the brackets, this represents a positive number. If I put the not outside the brackets, now that thing inside the brackets is negated, the outcome of that is negated, and effectively I get the opposite of that, which is it's a negative number. So if it's not a positive number, well, then it would have to be something that isn't positive, the negation of that. Okay, right? So, okay, so all the positive numbers are the numbers that are greater than 100, and any other number is going to be not a positive number. Okay, so that should work. So let's test it out. I'm going to copy down my system.out.println, and I will paste it in there. And I'll change the message, of course, to Q2, and we want to print out Q2 there as well. So I'll save that and compile. And we will execute. So we see Q2 now is equal to false, okay, as expected, because I gave x a positive value. I assigned it the value 2, which is a positive value. Okay, so let's assign it a negative value. So we should get a true if it's a negative value. So let's assign it -2, and we'll recompile. And we'll execute, and we get Q2 equal to true. Okay, so that's okay because -2 is not a positive value, or not a positive number, so we get a true there. Now, does that mean that it's only the negatives? Well, no, not really, because x is not a positive number. Just means, well, it's everything other than positive. So do you think 0 would be allowed? Well, 0 is not a positive number, it's a neutral number. So let's check and see what that would output. X equal to 0. We'll save that. What's your intuition about this? What do you think? Should it be true or false? Well, let's see. So we'll execute, and we get a true. Okay, and that makes sense because 0 is not a positive number. It's a neutral number. And all the negative numbers are not positive numbers. So 0 in this case is true. It's not a positive number. Okay, let's move on to the next one. x squared is positive. Okay, when we square a number, even if you square a negative number, you get a positive number. And if you square a positive number, you get a positive number. Okay, so how would we represent that? How would we represent x squared? Well, we could start to introduce a function here from the math library, but let's not do that. We can do this very easily by just multiplying x by itself, because that is x squared, okay? So let's do that. Let's assign x a value first of all. So let's say x is equal to, let's say -3. Oh, I need an equals there. As x is equal to -3. I'm typing things that I'm not saying, thinking about something else. Okay, x is equal to -3. All right, let's introduce our Boolean variable. This is question 3, so I'll say q3 equals, and in brackets then we want to say x squared. So that's just x multiplied by itself, x multiplied by x. That's the x squared bit. And I want to say that that's a positive number. Well, what are the positive numbers? All the numbers that are greater than 100. So x squared needs to be or greater than 0, greater than 100. So x squared greater than 0. Okay. Right. Now, the way this is going to work is, it's interesting just to break this expression down. This piece of the expression is an arithmetic operation. This x squared piece of the Boolean expression is going to be a number. It's going to result in a number. And then that number is going to be compared using that relational operator greater than. It's going to be compared in that way to 0. So once this line of code gets executed, this is the first bit that gets evaluated. This arithmetic expression part gets evaluated. And then we have some number then that is compared to 0 using the relational operator greater than. And the outcome of that, of course, is going to be a Boolean expression, because wherever you see an expression that has a relational operator, then the outcome is a Boolean value, true or false. And then, of course, that's going to get assigned to our q3 Boolean variable. Okay, let's print this out. So I'll copy my system.out.println statement down, and I will print out the value of q3. So, for a negative number and for a positive number, the output of this is going to be true. Okay, so we'll save it and we will compile and run, and we get a value of true. Okay, that's fine. So you can see how this expression breaks down. The arithmetic piece is executed first, and we get a value for that, and then it's compared to 0 using that relational operator. Okay, let's move on to the next one. X is an odd number. Okay, again, let's assign some value to x. I'll say x is equal to, well, we're checking for an odd number. X is an odd number. So let me assign x an even number value first. So since this is question 4 and 4 is an even number, I'll assign a value of 4 to x. And then what we want to do is use our Boolean variable q4 this time, and that would be equal to, how would we say that x is an odd number? Well, the way we do this is we divide the number x by 2. And if there is a remainder on dividing x by 2, then it's an odd number. If there's no remainder, if the remainder is 0, then it is an even number. So one of the things that we don't want to do is use the division operator. If we say x divided by 2, the division operator in Java gives us the whole number part of the answer on dividing x by 2. What we want is the remainder part, and we have a special operator in Java to do that, and that is the % symbol, and that is the modulus operator. So the modulus operator gives us the remainder on dividing x by 2. Now, when you divide a number by 2, you're either going to get no remainder, okay, because it's either an even number, or you are going to get a remainder it's an odd number. The remainder that you'll always get is 1, okay, because you're dividing by 2. So if 2 doesn't go in evenly, then the only remainder that you can have is 1, okay? But we're not interested in what the remainder is. We're just interested in, is there a remainder or not? Is it even? Is it odd? Okay, we're looking for an odd number in this case. All right, so you could say, well, x mod 2 is equivalent to 0. That would be an even number. Okay, so that would be checking for an even number. And then if you wanted to, you could negate that by putting a not out the front of the brackets. So then you're negating the piece in the middle and saying, okay, well, if it's an even number, then you flip that using the negation symbol, and then you have an odd number. Okay, but there's a better way to do that. We can do it, much easier by just using one of our relational operators, not equal to. So we can say x mod 2, I'll put my brackets back in, x mod 2 not equal to 0. Okay, so that's the better way to do it. That's the nicer way to do it. It's more readable way to do it, more understandable. So when we say x mod 2, so we're going to divide x by 2 and take the remainder part of that. And again, when this expression is evaluated, this arithmetic part is done first. So that x mod 2 will represent the number that is the remainder, which will actually either be 0 or 1. And then we will compare that against 0 using the not equal to relational operator. So you'll either get 0 not equal to 0, which would be false, or you're going to get 1 not equal to 0, in which case would be true. Okay, so this is how we would represent an odd number. X is an odd number because on the dividing x by 2, we should get a remainder. In other words, the remainder is not going to be equal to 0. Okay, let's check that out and see, is that the case? Because we have assigned a value of 4 to x, which is an even number, right? So when we test this out, we should get an output of, well, what do you think? What does your intuition tell you? Should it be true? Should it be false? Well, we're looking for an odd number, and we've given x an even number value 4, so we should get false, right? So we'll compile and we'll run, and we get Q4 equal to false, as we expected. Okay, let's assign it an odd number. Let's say 3. 3 is an odd number, and we'll save it and recompile and run the program. And now we get an output of true, which is what we'd expect because 3 is an odd number. Okay, let's move on to the next one, question 5. Okay, question 5 states that x is equal to 10 or 20. Right, okay, let's give x a value. Let's say x equals, let's give it a value. Well, let's give it a value that is not 10 or 20. So let's say 60. 60 is not a value that is 10 or 20, just to test this out. So how are we going to do this? Well, let's create our Boolean variable Q5 this time, and then I'm going to assign that equal to our answer. So how are we going to write this? Well, the clue is in the question, really. 10 or 20. So we're actually using the word or in the question. So that means that we should use our Boolean operator or. Okay, so we can write this as x equivalent to 10 or, and one mistake that I see students do from time to time when they're starting off writing these Boolean expressions down or practicing with Boolean expressions is often I'll see them write that expression as this. They'll just say 20. Okay, and that's incorrect. It's syntactically incorrect because either side of that or operator must be a Boolean expression. Okay, Each side of that must result in some kind of Boolean value. Now the left hand side does, because it's x equivalent to 10, but the right hand side, when you just put 20 there, that's just a numeric value. It's not a Boolean value. It doesn't evaluate to a Boolean true or false. So that's syntactically incorrect. Your program won't compile like that. So you must put the x on that side as well and say x equivalent to 20. And that's the way you write that. Okay, and sometimes that can result in reading the question literally, equal to 10 or 20. Okay, so it's just something that you have to get used to doing. But that's the right way to write it down. Okay, so x is equivalent to 10 or x is equivalent to 20. And we can test this out by copying our system output down, and this is question 5, so we'll say q5 and output the variable q5. We've assigned x the value of 60, so we should get an output value of false for this. So let's save it and compile it and run it, and we get a output of false, q5 equal to false. Okay, that's not unexpected, that's what we wanted. So let's assign x one of those values, either x or either 10 or 20. So let's assign it the value 20, and we'll recompile and execute, and then we get an output of true. Okay, so one of the other things that I'd like to just point out about this OR operator that we're using is that in Java, the OR operator is the inclusive OR operator. So what does that mean? Well, in English, the use of the word OR is a little bit ambiguous because, we can say things like, would you like a cup of tea or coffee? Now, when we say that to somebody, we hardly expect them to say both. Okay, it's one or the other. It can be tea or coffee, but not both. Okay, but other times we actually might say something like, that jumper can be worn during the summer or winter. Okay, so in that case, the or is understood to mean the inclusive version of or, because, well, you could wear the jumper in the summer and winter. You can decide to wear it in both seasons if you want. Okay, there's no rule against that. So that version of the or is inclusive in that you could wear the jumper in summer and winter if you wanted to. But in the other example where we're talking about would you like a cup of tea or coffee, that's the exclusive version of the or, where it's one or the other but not both. In Java, this operator, this symbol here that you see, is the inclusive version of the OR operator. There is an exclusive version of the OR operator. I'm not going to cover that in this video. I'll leave that for some other time. Okay, so let's save this and compile it and run it. So let's compile and run. And this time, okay, we've set x equal to 20 and we get an output of true. Okay, so let's move on to the next one. Okay, so the next one states that x is in the range 0 to 10 inclusive. X is in the range 0 to 10 inclusive. Okay, so for this question, we're not checking to see if x is a singular value. We're checking to see if x is in a range of values, and the range of values that we're interested in is 0 to 10. So x could be equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it should include 0 and 10. Okay, so again, let's just assign x a value, and I want to assign it a value outside of that range just for testing purposes. So we'll say x is equal to 11, just for example. Okay, so we will create a new Boolean variable here, which will be called q6, and I'll set that equal to And how are we going to do this? Well, usually when we want to create a range, we use our relational operators: greater than, less than, greater than or equal to, and less than or equal to. And we use those in combination with our and Boolean operator. And this is how we do it. We say x is greater than or equal to the first number in our range, which is 0. And x is less than or equal to the last number in our range, which in this case is 10. Now, because we're using greater than or equal to and less than or equal to, that means that x can be a number that is equal to 0 or greater than it, and x can be a number that is equal to 10 or less than 10. And that will include all the other numbers in that range from 0 to 10, all the numbers in between, because x is a number that is greater than or equal to 0, and that and is the critical piece there, and it's a number that can be less than or equal to 10. Okay, so we can print out our answer and check that out and see what value we get. So this is question 6, and I'm going to put in Q6 there as well. So I've assigned the variable x a value of 11, which is clearly outside of that range. So we should get a false in this case. So let's compile the program and let's run the program, and we get a value of false. Okay, that's not unusual, that's expected. So let's give it a value that is inside the range. So just to show you that it includes the 0 and the 10, let's say we'll give x a value of 10. Okay, we'll try one of the boundaries of the range out just to be sure. So x is equal to 10, so let's recompile, and we will execute the program again, and we see that Q6 is equal to true, because yes, 10 is in the range 0 to 10 inclusive. Okay, let's move on to the next one. What does the next one say? Okay, question 7, we have x is an even number in the range 1 to 100 exclusive. Okay, so there's a few things happening in this question that we need to be a little bit careful of. And, you know, if you read the question, you might say, that's a little bit silly. Why would you say 1 to 100 exclusive? Why don't you just say a number in the range 2 to 99, okay? And that's a fair enough point. Okay, I take that. But what I'm doing is I'm trying to engineer these questions to get you to kind of think about the relational operators in a certain way, okay? So, you know, these are the questions are a little bit silly, but that's not the intent of the video. The intent of the video is to kind of get you to use the relational operators that we have so that you get a bit of practice in doing that. Okay. So the way I'm going to do this one is I'm going to break it down first of all into, well, let's represent x as an even number, and then let's deal with the range part of the question then as a secondary thing. Okay, so I'm going to assign x a value first of all. So let's say x is equal to, I'll assign x equal to an odd number. So since we're on question 7 and 7 is an odd number, I'll assign x the value 7. For no other reason than that. Okay, and then what I'll do is I'll create my new Boolean variable here, Q7, and we'll set that equal to, and the first thing is I want to deal with the first part of the question, which is x is an even number. So we've done an odd number before, so let's do that for an even number. So x modulus 2 is equal to 0, so no remainder. So remember, x mod 2, well, the modulus operator gives us the remainder on dividing x by 2. So that's an arithmetic operation that's going to give us a number. In fact, that number will either be 0 or 1. And then that will be compared using the equivalence operator to 0. And then we'll get a truth value from that Boolean expression. Okay, so that's the even number part, but also I want it to be an even number in a certain range. So I'm going to say, well, and also, as well as that, I want it to be in the range 1 to 100, but this time I want it to be exclusive. So I wanted to exclude 0 and 100. Okay, so what I'll do is I'll say x greater than 1 and x less than 100. Okay, so in this case, when I say x greater than 1, well, what's the next value greater than 1 that x could possibly have? Well, it would be 2. And when I say x less than 100, well, what's the next value down from 100 that x could possibly have? Well, it's 99. So effectively, we're creating a range here from 2 to 99 by leaving out the greater than or equal to, making sure that x can only be a value that is greater than 1, and by leaving out the equal to here, the less than or equal to, and saying x is less than 100, ensuring that x can only be a value that is less than 100. And in between that, x can have any value that satisfies that range. Okay, so that's how we can do that. And again, we can print out our answer. So this is Q7, and we'll print out Q7 as well here in our output. We've assigned x the value of 7, which is an odd number. So what's going to happen there is that this even part of the Boolean expression will evaluate to false because 7 is not an even number. And if you know your AND truth table, you'll know that in an AND operation, both sides, the left side and the right side of the AND, must evaluate to true in order for the entire outcome to be true. Okay, so in this case, it's going to fail. It's going to result in a false because this part is going to evaluate to false. Okay, so we'll save that and compile. And we'll execute. And we get Q7 equal to false. Okay, that's as expected because 7 is an odd number. Okay, let's also test out this range piece. Well, what about if we said x was an even number but outside of the range? So let's say we said x was 144. Well, 144 is an even number, but it's outside of the range. So with 144 assigned to x, now it's this part of the expression, the right-hand side of the expression, the range piece, that will fail because x is not in the range 2 to 99 or 1 to 100, excluding 1 and 100. Okay, so it will still fail. It will still result in a false, but for a different reason. Okay, so we'll execute and we can see Q7 is indeed still false. So the only way that we can make the output of this expression to be true is to give x a value that is even and also in the range 1 to 100, or as we know, 2 to 99. So let's do that. Well, 64 is an even number and it's in that range. So we should get an output of true this time. So I will compile and run, and now we get a value of true. Okay, let's move on to the next one. The next one states that m is a valid month number. Okay, I've got a different variable this time, m, so I'll introduce a new variable, m. I'll say m is equal to 13. Okay, I know 13 isn't a month number, but bear with me. We're going to test out the kind of negative case first. Okay, so m is a valid month number. All right, well, let's put in our Boolean variable for this. This is question 8, so I'll say Q8 is equal to... Okay, now for this answer, what you might be tempted to do is to say m equal to 1, or m equal to 2, or m equal to 3, or m equal to 4. And you can kind of see where I'm going with this, can't you? I'd have to say m equal to 5, m equal to 6, 7, 8, 9, 10, 11, 12 for all the different month numbers, okay? All the valid month numbers. But month numbers are in a range. They're from 1 to 12, inclusive, including 1 and including 12. So once you know that they're in a range, well, you can write it down as a range. Okay, so let's do that. It's better than writing it out individually for each month number. Why would you do that when you can do it in a shorter, more meaningful way? Okay, so you can say m greater than or equal to the first month number, which is 1, and m less than or equal to the last month number, which is 12. Okay, so that is an awful lot better. That's, less code to write, and it's also kind of more meaningful in that, you're seeing that month numbers are a range. They are a continuous series of values from 1 to 12. So, it's better to treat them like that. Okay, so let's print that out. So we'll copy down our system.out, and I'll change this to Q8, and we'll print out the variable Q8. Okay, and remember, I've assigned m equal to the value 13, which is clearly not a month number, so we should get an output of false. So I'll save that and compile. Oh, I didn't compile there, sorry. I will compile first, of course, and then I will execute, and we get Q8 equal to false. Naturally enough, because m equal to 13, 13 is not a month number. So let's assign it equal to a month number. Seeing as though it's December, let's put in 12. And now when I recompile and execute, I should get true. And I do. Q8 equal to true. Okay, let's move on to the next one. The next one states that, I'll have to make my text a little bit smaller here. So the next one states that D is a valid day number, but not Wednesday. Okay, so valid day. Okay, well, the days of the week are like, from 1 to 7. And in the question, it also kind of tells us that we should assume that Monday is day 1. Okay, so Monday is day 1. Okay, so that means that Wednesday is day 3, okay, because the question says that D is a valid day number but not Wednesday. So Wednesday would be day 3. Monday 1, Tuesday 2, Wednesday 3. Okay, so let's introduce D first of all, because that's a new variable that we haven't come across. So I'll say int D equal to, and I'll set it equal to 3 to start off with. Okay, D equal to 3, which would be Wednesday. And then what I want to do is I want to again break this expression down a little bit. So, well, what would a valid day number be? Let's do that bit first, okay? So we'll say Boolean, and we're on question 9. So Q9 is equal to, so a valid day would be, well, the days are also in a range as well, aren't they? 1 through to 7. So I can represent that as a range. I'll say D greater than or equal to 1, the first day, and D less than or equal to 7, the last day, which would be Sunday. Okay, so that's a valid day. Now, I want it to be a valid day, but not Wednesday. So Wednesday is day 3. So I want it to be a valid day and not Wednesday. How would I do that? Well, D not equal to 3. That will do it for me. So this represents the first part, the left-hand part of that and is the valid day, and the right-hand part is but not Wednesday. So D not equal to 3. So saying that it's part of the range and also not equal to 3, that's perfectly allowable, and that's a nice way to write that down. Okay, so we can test that out. I will copy down my system.out.println, and I'll change my message to Q9, and then of course we want to print out Q9 as well. So I'll save that and compile, and let's run the program, and we get an output of false. Okay, expected because I said D equal to 3, which actually is Wednesday. Wednesday would be day 3. If I set that equal to, let's say, a Thursday, which would be 4, day 4, then I save it and I'll compile it again and let's execute it. Of course, we get the output true now. Okay, but there's another way to do this. There's another way of thinking about this problem, and that is to actually split the day ranges up into 2 different ranges. So Wednesday is kind of in the middle of the week, and that's the one that we want to avoid, or the one that we want to kind of skip over. So what about if we made a range of days that came before Wednesday and a range of days that came after Wednesday and excluded the piece in the middle that we didn't want, which is just a single day in this case, which is kind of day 3. So what we can do is actually represent this with 2 ranges rather than 1. Okay, so what I'll do is just to illustrate this, I will comment out that solution that we've just done, and I'll put in an alternate one, which is using the 2 ranges. So Boolean Q9 is equal to, and we'll have 2 ranges. So we'll have a range of days that come before Wednesday. So that will be D greater than or equal to 1 and D less than or equal to 2. Okay, now this is a little bit silly in this case because, well, there are only 2 days that come before Wednesday, right? That's day 1 and day 2, which is Monday and Tuesday. So there is only really 2 numbers in this range, but let's just go with it because, I'll explain why this approach might work in other situations in a minute. Okay, so that's the range of days before Wednesday. And what we want to do now is we want to include the range of days that come after Wednesday. But when you think about it, a day can only be in part of the week that comes before Wednesday or in part of the week that comes after Wednesday. It can't be both. Like if you're Tuesday can't come before Wednesday and after Wednesday. So it would be wrong to use an and here in the middle. What we need to do is we need to use an or, because it's either in the first part of the week or the second part of the week and not Wednesday, okay? So we need to use an or there, not an and. It isn't possible for it to be in the first part of the range and the second part of the range. Numerically, it can't work, okay? If you think of your number line, it can only be one number on the number line. It can't be in 2 places at once. Okay, so it has to be an or. All right, so we'll say or D greater than or equal to, well, what we remember, we want to skip over day 3. So the first day number we need to include in the second part of the range is day 4. So D greater than or equal to 4 and D less than or equal to, well, what's the last day of the week? Well, that's 7. Okay, so this will also work. It's also correct. But where you might want to do this is, let's say you had a much larger range and there were more numbers in the middle. Let's maybe say like a whole series of numbers all beside one another in the middle of the range that you just wanted to skip or avoid. Then this approach might be better for that type of situation. But we're only dealing with a small enough range in that it's only the numbers 1 through 7. And in this case, we just want to avoid a single day. So the first solution is kind of a little bit better for that situation. But if it was a larger range and more numbers that you wanted to hop over in the middle, then the second approach might be a bit better for that. Either way, both of them work, okay? So for example, if I set D equal to 3, just to show you that that second approach works, we should get a value of false now because it won't satisfy both of those ranges. 3 is the one that we want to hop over. So let's see, does it work? We can recompile and run the program. And again, we get an output of false, which is correct. But if I select any other day of the week, either in the first part or the second part. Let's again pick, say, Thursday, for example, and I run the program again. And let's execute, compile and run. Okay, so we get a true value now again for question 9, which is what we would expect. Okay, last question eventually. So y is a leap year. Well, again, I have a new variable here, y. So let me just firstly introduce that int y, and let's assign it a year value. Let's say the year 2019. Okay. And what we want to do is we want to represent a leap year. Okay, so since we first start counting years in our calendar, every 4 years is a leap year. Okay, so that means that if you divide the year number by 4 and you don't get a remainder, in other words, if the year is evenly divisible by 4, well, then it's a leap year. So we can use our modulus operator to do that. Okay, so let's say Boolean Q10 is equal to y mod 4, and if it's evenly divisible by 4, there'll be no remainder, so we'll say equivalent to 0. Very much like our check for even and odd, and we can check to see if any number is evenly divisible by any other number using the same kind of expression. So that's okay, but actually the rules around leap years are a little bit more complicated than that. Unfortunately, it's not that easy. What we want to do is we also want to avoid any other century year. So if it's a century year, then it's not a leap year. Okay, so a century year, well, that's every 100 years, isn't it? So what we wanted to say is that, and if y mod 100 is not equal to 0, so that represents not a century year. If it was a century year, it would be a year that would be evenly divisible by 100 and you'd get a 0 remainder. But we want not a century year. So it's y mod 100 not equal to 0. Okay, everything good so far? I think so. Actually, no, there's another little wrinkle in this check for a leap year, and that is that actually every year that is divisible by 400 is allowed to be a leap year. Okay, so not a century year. Hey, but if it is a year that is divisible by 400, then it is allowed to be a leap year. Okay, so how are we going to do this? Well, we can just simply say, or if it is a year that is mod 400 equivalent to 0, then it's allowed to be a leap year. Okay, so how does this expression work overall? All right, well, let's look at this second set of brackets here, first of all. Okay, all right, this represents that it is not a century year. All right, because the remainder not equal to 0. All right, if we wanted to represent a century year, that would be equivalent to 0. So divide y by 100 and you don't get a remainder. We want it to be not a century year, so that's why we say not equal to 0. Okay, so this is not a century year, and this piece over here represents a year that is evenly divisible by 400. So if either of these are the case, if one of these is the case, then this whole set this whole set of brackets will evaluate to true. If you know your OR truth table, you'd know that just one side of this OR has to evaluate to true in order for the outcome to be true. So if it's not a century year, or it is a year that is evenly divisible by 400, and it is a year that is evenly divisible by 4, then it is a century, or then it is, I'm even getting confused myself, then it is a leap year. Okay, so that's a little bit of a tricky one to get your head around. Okay, but that is the correct way to check for a leap year. Okay, let's test it out. Let's print out our Boolean variable Q10 and see what happens. Okay, so Q10, and change that to Q10 as well. Save that and let's compile and run. And we get Q10 equal to false, which is what we would expect because we've put in 2019, which is clearly not a leap year. Let's put in something that is a leap year. Well, as it turns out, our wonderful current year, 2020, such a great year it has been, is a leap year. So let's put in 2020 and test this out. Okay, so I'll save that, compile again, and let's execute. And we get Q10 equal to true, because 2020 is a leap year. Okay, so hopefully after going through all of those questions, and I know it was kind of tedious and laborious and maybe even a little bit boring, but guess what? These are the building blocks that you need to know in order to construct conditional blocks in your program. This stuff is really important, you know. The more practice that you get with these relational and Boolean operators, the more comfortable you're going to be in creating conditional blocks in your program. This stuff kind of has to be just really natural to you. And the only way, unfortunately, the only way that it becomes natural is by just practicing these Boolean expressions. And a good way to do that is to kind of take English sentences and try and represent those using Boolean logic. It's very good practice. So if you come across sentences like this, why don't you try that? Why don't you actually try and translate some English sentences? You can even make them up yourself. Try and translate them into Boolean logic using our relational operators and Boolean operators. So hopefully you have found this video useful. If you have, please subscribe to the channel and please like and share and comment on the videos. And as I said earlier, if there is something that you'd like me to cover, comment on one of the videos, and if I can, I'll try and include it in an upcoming video. So thanks a lot for watching, and I'll see you in the next one.